are going to start questions related to continuity. Write down the first question. Testing the continuity of a function at a point when the function has same definition on both sides of given point. Suppose we have function f of x as modulus of x upon x. X is not equals to 0, 1 when x is equals to 0. Now first find left hand limit. Limit x tends to left hand limit, so negative sign here, 0, negative. This is number line 0, infinity, minus infinity. Left hand limit negative, so 0, negative. Function f of x. F of x is modulus of x upon x. If we want to write it as limit h tends to 0, then instead of x we put the value as 0 minus h upon 0 minus h. Is it clear? When here the positive limit, right hand limit 0 positive, then instead of x we will put 0 plus h. So we write it as limit h tends to 0 upon minus h. Limit h tends to 0 upon minus h. Now modulus of negative number is also a positive number, so h upon minus h. Limit h tends to 0. So we get the value minus 1. Now if we are solving right hand limit, then we will write it as limit x tends to 0 positive. So when we write it as limit h tends to 0, so 0 plus h upon 0 plus h. Limit h tends to 0, modulus of h. Modulus of h is h. H upon h is 1 and function की value f of a here is 0. So function की value at 0. F of 0 is 1. Now left hand limit is not equals to right hand limit. Right hand limit or function की value at that point is equal, but it is not equals to left hand limit. Therefore the function is not continuous at x is equals to 0. Therefore function is not continuous at x is equals to 0. Now next question. Show that the function f of x given by x sine 1 by x is not equals to 0, 0 when x is equals to 0 is continuous at x is equals to 0. We want to prove that the function is continuous. Left hand limit, limit x tends to 0 negative, f of x is x into sine 1 by x. When x is not equals to 0 means when x is less than 0 or greater than 0, then the function has value this. So we can write it as limit h tends to 0. Then what we have to do? Instead of x we put the value 0 minus h. 0 minus h is minus h. Limit h tends to 0, negative of h. Now sine of minus theta. Sine of minus theta is minus sine theta. So put this value here. Sine of minus theta is minus sine theta. So here we put the value 1. Clear? Now limit h tends to 0. H into h is 0. 0 into sine this will be 0. Now right hand limit. Limit x tends to 0 positive. Limit h tends to 0, 0 plus h. Sine 1 upon h. So we will write it as limit h tends to 0, h sine 1 by h. H is 0, Limit h tends to 0, so 0 into something is 0. And function की value at that point at x is equals to 0, function has value 0. So left hand limit is equals to right hand limit is equals to value of function at that point. Therefore, function is continuous at x is equals to 0. Now the next one, show that the function f of x given by sin x upon x plus cos of x when x is not equals to 0 to when x is equals to 0 is continuous at x is equals to 0. So first we will have to find left hand limit. Limit x tends to 0 negative sin x upon x plus cos of x. We can write it as limit h tends to 0 sin of 0 minus h upon minus h plus cos of minus h. Now we know that limit x tends to 0 sin x upon x is 1. So limit h tends to 0, sin of minus theta is minus sin theta, minus will get cancelled here, plus cos of minus theta is cos theta. Limit x tends to 0, sin x upon x has value 1, plus cos of x tends to 0, cos 0. Cos 0 has value 1, so 1 plus 1 we get 2. Now right hand limit. Limit x tends to 0 positive sin x upon x plus cos of x. We can write it as limit h tends to 0, 0 plus h. Clear? 0 plus h plus cos 0 plus h. Separate the limits. Sin h upon h plus limit h tends to 0, cos of h. Limit h tends to 0, sin h upon h 1 plus cos 0 has value 1, 2. And value of the function at that point is given 2. So left hand limit is equals to right hand limit is equals to value of function at that point. Therefore, the function is continuous at x is equals to 0. Now the next one, examine the function f of t given by cos of t upon pi by 2 minus t when t is not equals to pi by 2, 1 when t is equals to pi by 2 for the continuity at t is equals to pi by 2. Now we want to check the continuity at the point pi by 2. So left hand limit first. Limit x tends to not 0. Now the limit we want to check at point pi by 2. So pi by 2 negative. Instead of x we have function in t. So limit t tends to pi by 2 negative. Cos of t pi by 2 minus t. Now when we put the limit h tends to 0, so we will write it as cos pi by 2 minus t, and instead of t, pi by 2 minus t. Is it clear? Now cos of 90 minus theta. Cos of 90 minus theta is sin sine theta. So instead of this, we write it as sine t minus minus plus t. So limit h tends to 0, sine h upon h here we put h, sine h upon h is 1. Now write in limit t tends to pi by 2 positive cos t upon pi by 2 minus t. So limit h tends to 0, cos of pi by 2 plus h, pi by 2 minus pi by 2 plus h. Now cos of 90 plus theta is minus of sine theta. So minus sine h upon minus h. Cos of 90 plus theta is minus of sine theta. And limit h tends to 0, sine h upon h is 1. Now value of function at pi by 2 is given 1. So left hand limit is equals to right hand limit is equals to value of function at that point. Therefore, function is continuous at t is equals to pi by 2. Show that the function f of x given by e power 1 by x minus 1 upon e power 1 by x plus 1 when x is not equals to 0, 0 when x is equals to 0 is discontinuous at x is equals to 0, is discontinuous at x is equals to 0. Now left hand limit x tends to 0 negative 1 upon x minus 1. When limit h tends to 0, h tends to 0, we write it as 0 minus h. First, take e power 1 by x common. Limit h tends to 0. E power instead of x 0 minus h. Instead of x 0 minus h. In the denominator we have plus sign here. We know that limit h tends to 0, 1 upon e power 1 by h. When we put h tends to 0, so 1 upon 0 infinity, 1 something upon infinity, then we have value it equals to 0. So we can write it as 1 upon e power 1 by h. So 0 minus 1 upon 0 plus 1. So we get minus 1. Now right hand limit x tends to 0 positive. Limit h tends to 0. So e 1 by h minus 1, e 1 by h plus 1. We can write it as, by taking e power 1 by h common, 1 minus e power 1 by h, 1 plus e power 1 by h. It will get cancelled. 1 minus 0, 1 plus 0, that is 1. And value of function at that point is 0. So left hand limit is not equals to right hand to value of function at that point. Therefore, the given function is discontinuous at x equals to 0. Therefore, given function is discontinuous at x equals to 0. Next one is discuss the continuity of the function f of x at x is equals to 1 by 2, where function f of x is equals to 1 by 2 minus x, 1, 3 by 2 minus x. 0 is less than equals to x less than 1 by 2, x equals to 1 by 2, 1 by 2 is less than x less than equals to 1. We want to check the continuity of the function at point 1 by 2. Now left hand limit x tends to 1 by 2 negative. When the function f of x has value less than 1 by 2, x is less than 1 by 2, this is the case. So for this x is less than 1 by 2, we write the value of function as 1 by 2 minus x. Clear? Now limit h tends to 0. Instead of x, what we put? 1 by 2 minus h. 1 by 2 will get cancelled, minus minus plus. Limit h tends to 0. H is equals to 0. Now right hand limit x tends to 1 by 2 positive. When x is greater than 1 by 2, 1 by 2 is less than x, or we can write it as x is greater than 1 by 2. So this is the value of function when x is greater than 1 by 2, when the limit is right hand limit. So we write it as function value as 3 by 2 minus x. 3 by 2 minus h, limit h tends to 0. Instead of x, what we will write? 1 by 2 plus h. So we can write it as 3 by 2 minus 1 by 2. 3 minus 1, 2 by 2, 1 minus h. So after putting the limit h tends to 0, we get the answer as 1. Now value of the function at x is equals to 1 by 2. That is given 1. Now left hand limit is not equals to right hand limit, but right hand limit is equals to value of function at that point. Therefore, function is discontinuous at x is equals to 1 by 2. At x is equals to 1 by 2. Note it down. Next one. Discuss the continuity of a function fx given as 2 minus x when x is less than 2, 2 plus x when x is greater than equals to 2. We want to check the continuity of function at x is equals to 2. x is equals to 2 पे हमें check करना है कि either function is continuous or discontinuous. First find left hand limit. Limit x tends to 2 negative. X is less than 2. Then the function is value 2 minus x. Limit h tends to 0. Instead of x, 0 minus h. So we write it as 2 minus minus plus h. Put the value of limit. So we get the answer as 2. Now right hand limit. When x is tends to 2 positive. When x is greater than 2, function has value 2 plus x. So limit h tends to 0, 2 plus 0 plus h. Limit h tends to 0, 2 plus h. H is 0, so we get 2. Now value of function at x is equals to 2. Function has value for x is equals to 2. This is the value. So when we put x as 2, so 2 plus 2 is equals to 4. Left hand limit is equals to right hand limit. Left hand limit is equals to right hand limit but not equals to value of function at that point. Therefore, function is discontinuous at x is equals to 2. Function is discontinuous at x is equals to 2. Now next one. Show that the function f of x is equals to 5x minus 4 when 0 is less than x less than equals to 1, 4x cube minus 3x when 1 is less than x less than 2 is continuous at x is equals to 1. We want to check that this function is continuous at x is equals to 1. So find the left and right hand limit. Left hand limit, x tends to 1 negative. When x is less than 1, then function has value